Okay, Amit, could you start off by explaining to me what the VedaViz tool is, what it does?
Okay, VedaViz is the web version of a suite of tools which are called Veda. Veda is a Sanskrit word which actually means knowledge. So the idea here is that we convert a large amount of information into knowledge by allowing people to slice and dice information, mainly coming out of large data intensive models. So basically with this tool we can create different views of the results. We can aggregate, we can select very dynamically, and we can juxtapose different dimensions meaning we can put scenarios together, we can put years together, we can put regions together, just so that we can place things that we are actually looking to compare close to one another.
So it's very, very visual.
It's very visual and very easy to configure things around, to throw things around on screen.
So it's got a number of different features. Could we have a look at the charts feature first?
So to show you the charts, I will select a US model, which is a very detailed bottom-up model of the US energy system that we have been using for some time. So this has been run for some shale gas scenarios and some carbon price scenarios. So let's see how we can progressively look at more and more detail in results.
Okay.
So we start with the total electricity generation that happens in the reference case. So you see, this is the name of the model.
Right.
This is
USA.
the USA. This is the scenario, and this is electricity production. So we see that it increases from like 14 something to 19 something over
time.
40 years.
Yeah.
Right. Now we want to see what's the breakup of this total, that how much of this comes from coal, how much from gas. So we can look at a stacked column view of this.
Oh, okay.
So now we see the black is coal, the purple is gas. And if you want to see now where geothermal is, then if you go and click on this, well, actually it's too small. If you click on hydro, then it draws a box.
Yeah.
Right, and it draws a box, and if you go here, then it shows you the number. And actually you have access to all the numbers all the time. If you go here, you see all the numbers which can be downloaded directly to Excel.
But that visual image there is so much easier to read than that Excel spreadsheet.
Well, it depends on what you want to do. If you want to, well, do some other analysis, compute some elasticities, but it depends on the person who's doing that now. So yes, so now we have the breakout for one, but we always have to compare things. You know, a single scenario is never enough because it's all about comparing things. What happens when you put a carbon price? What goes up, what goes down, how much, when? That's the kind of stuff you want to know. So we bring two scenarios. Okay. So this is the reference case and this is the carbon price case.
Yeah.
So we see that coal, of course, the polluting one, it goes down. It almost reduces to zero. There is more biomass, the green. There's more nuclear as you go out.
And you've got a different curve here. That's our original curve, isn't it?
Right.
This one's different.
So this means that there is some electricity saving going on as you have to reduce emissions. So not only do you produce electricity differently, you produce less of it. You use energy conservation measures. So, well, let's get some more. We get greedy. We want to look at 4 scenarios since it's so easy. Now, the 2 additional scenarios that we bring in have to do with shale gas. So this is attractive availability, easy availability of shale gas. This is low availability of shale gas. So see, you compare this versus that. Now you see there is more purple here and there is less purple here.
Can you isolate any parts of these? Because we're having to try and look at 4 places on the screen, aren't we?
Exactly. So that's the dicing part of it. Now, first of all, let's reduce the number of years. Now we are, see, so far we've only looked at the views that were saved. Now for any of these views, we can readily change the selection. And this is what I've opened the left panel now. So I want to look at now only 4 years. So I select 20, 30, 50 and that. So we'll see smaller graphs now. Right. So you see 2012, 20, 39, 50. Yeah. So now like you said, now I would like to get this these columns in the same chart so that I don't have to wander from here to here to here and see how much what is changing. So what I need to do is I need to get the scenario from the chart title to the x-axis, and I will take the x-axis to the years to chart title so that I get 4 charts for each, one chart for each year. So I can do that very visually by, see, scenario is a multi, so I drag it down to the x-axis.
Okay.
And the year that was sitting on the x-axis has actually now been added to the series. So it's not very useful there. I bring it to multi so that we get one chart for each of the years that we're looking at. Now what this will do is that put the scenarios that we wanted to compare close to each other. So you see, when you go from base to shale, you get larger amount of gas. And what does it replace? It replaces coal, because coal has gone down and this has gone up. So this to show you that how easily you can juxtapose different things so that you can compare readily and not have to mentally remember and compute things. What we can do is to see how animate across these 4, because when things move on screen, then it's a lot easier to see what is changing. So now see, this is low shale case. If you put your mouse here,
is that the different scenarios?
Now, right, this was actually the base.
Okay, yeah.
Okay, now this is the base case, and you put your mouse here, then it transforms into the carbon case. So you know what has changed. Now from carbon to high shale, it goes like that, from high shale to low shale. So you can easily see what is changing. You can see that gas is basically compressing coal.
And of course you could show this to colleagues in real time, couldn't you?
Right. No, this is all in presentation, and you can even do an autoplay of this. So while you are presenting to an audience, this can be in the background, and you can be talking about the dynamics that underlie.
Great. It has. I noticed it had got some other functions along the bottom. There was a maps function. Could we have a look at that next?
Right. Okay. So these are the summaries of various power plants and production sites for the whole country. And now, if you want to look at regional detail of this, then in this particular model there is a very, very high degree of detail on that front. So let's see, where are the existing nuclear and coal plants located in the US. So this is showing you 212, and this will show you the capacities of existing power plants. So we'll see 2 types of markers in this picture. The black will show coal and the orange will show nuclear. And they are scaled according to the capacity. So if you click on this, then you see the unit information, because see, each plant has several units.
Yeah.
So this is a power plant that has 3 different units. These are the names and these are the capacities. And so the scaling, now this is the total is 7.89 gigawatts. So that's a larger one. If you look at a smaller one, and that's 0.058 only, and it has only 1 unit.
Yeah.
So that's a coal plant. Now, on this one, we are, thanks to Google Maps and EPA that releases the GIS coordinates of each one of these, we can even look at the plant.
Oh, fantastic.
So, of course, we can do it only for the existing ones. We don't have pictures for the new ones. And so this shows you what kind of facilities this particular plant has.
You can even get a sense of the environmental impact of the power plant, can't you? Because this one looks like it's way out in the middle of the desert.
Right, that's the nuclear one. So if you look at a large coal plant, let's see what kind of ash cloud it produces. So you see this, you can now see the coal handling facility of this, and you can see how it might be getting its coal.
Yeah.
I don't see a railway line here, but it might be.
And that's on the edge. Is that a lake?
Yeah, that must be involved in the cooling of this plant. But then there must be a railway line somewhere, because it doesn't have a canal close by for barrages.
Yeah.
Okay, so Right, now this is to see the location, but you can actually also see very useful things with this, that if you want to know that if you put a carbon price, or if there is very attractive or there is low availability of gas, then both these would impact the way coal plants retire. There's a certain retirement in the reference case. Now, if you put a price on carbon, then you would expect retirements to increase.
Yeah.
So this is the retirement in reference case. And notice how all the other pictures align when I move and zoom one of them.
Right. So when you zoom into one place,
right,
the others all zoom into the same place.
Right. So this shows the retirement of plants. So each one of these is actually a negative number. So, but it is very, very interesting to see that which areas of the country would see coal plants going out of service because of. So this is the regular reference case retirement because they are just too old. Then if you put a carbon price, if there is a carbon price, then you see distinctly higher retirements.
Yeah.
Because more plants have to shut down because they have to give way to wind and solar and gas. So the map thing that we've seen so far is process level, that we see individual plants on the map. But we can also see summaries on the map, the mixes, that how does the production mix look for each region? Because so far we saw US level thing, but there are 33 grids in the US which are modeled separately in our model. So this map is showing you that what are the imports and exports by grid. So the red one is the import and the green one is the export.
Is this different American grids sharing with other adjacent grids? Are they sharing products with each other?
Yes, they are trading electricity, and that's what we'll see in the very next view. So I just selected that apart from showing me the import and export summaries, now it also shows me where does electricity go from where. And if you click on any of these, it shows you that this is the exporting region, this is the importing region, and that's the level. So that's 125 tera-BTU being exported in this year 2025 in this scenario. And of course, as usual, the real game is in comparisons. So you can readily compare the trade patterns in different scenarios or different years on the same screen. And you can have pie charts on each region, which shows you the production mix. So you will see that this screen has a tremendous amount of information. This shows you that in this particular scenario in 2050, this is how electricity is produced in each one of these grids, and this is how it is traded. So now when you go from carbon to grid expansion, so these are all carbon scenarios, but the nuclear and grid expansion assumptions are different.
Right.
So this one allows nuclear, so you see a lot of oranges there because nuclear is preferred.
Yeah.
And in this picture, that's gas.
Yeah.
So that's gas, and probably with CCS because that might be adding the CCS and non. So you see there's a lot more solar and wind. The pink is wind and yellow is solar compared to, and there's not so much.
And here's a scenario, look, with no coal at all.
Right. So that's because it is doing it with gas, because this is an attractive gas scenario.
Right.
So whatever little coal was left, because because nuclear is zero emissions, so you can tolerate some emissions from coal. But when you go the gas route, then you don't have any possibility for coal. And so this is a very rich way of presenting information because you show the mix as well as the trade patterns on the map. And just see that this kind of information is impossible to see in text, because you will not be able to see that this is the Midwest where there's a lot of wind potential and how far it goes and where it goes, and it's really impossible to make this mental image just from text.
Whereas it's been really easy for me to pick up on the different scenarios, and look, there's one there without coal, and there's another one with very, very low coal. It's just very visual, isn't it?
Right. Now you can see the detail of the composition here. So you see that this is gas. This is the attractive gas scenario. That's a little biomass, that's wind, and that's nuclear.
Yeah.
And you can actually leave it alive and open it in this one. So you see how this compares with that
Yeah.
one.
So this is we've been looking at energy so far, but I think this does climate models as well, doesn't
Right.
it? So can we have a look at one of the climate models?
Okay, so now I'll take you to the TM model, which is our global model, TM world, and show you how we can plot the climate data that we get from the Plasm model using the system. So now what we see here is the cooling degree days, so which is a measure of how hot things are.
Okay.
So this is the way we measure the extent of heat, because this is the number of degree days that we have to cool across the year. So the scale here is that if it's blue, then it's 0, that you don't need any cooling, it's already cold enough. And the dark red, it goes up to like 2500 degree days.
Right, okay.
Okay. So let's look at Middle East, Western India, that region. And now as I do that, it will
And it zooms in on
and it zooms
the
in
other
on
views
that.
as well.
Right. So you see in 210, this is what it looks like. And you'll see that the squares are becoming darker and darker as you go out into the sanctuary. And this is the reference case, so of course the emissions increase quite a lot.
Yeah. So this is actually a lot of hotter days.
Right, a lot of hotter days, because this is almost in the 2500 degree days per year range, whereas the colors were a lot lighter here.
Yeah.
So then we can go and look at the US, how it fares in the same. So now you see the northern part, Wisconsin and everything was almost
and now
light.
here, look.
And now even here it's becoming much hotter. So that's the other kind of information we can get, and we can actually eventually overlay the power plants and everything in the same picture to see the energy and climate results together.
Okay. So I think there's a motion comparison feature as well, I noticed. Can we have a look at that next?
Right. Yeah, see, what we have seen so far is essentially in terms of conventional ways of visualization. It is just that we have made it very easy to select and to juxtapose. But there is also use for some different technologies to actually even visualize when you want to look at a even higher volume of information in the same screen.
Right.
So for that I will use results from a Japanese model with which we ran 100 plus scenarios. And for a little background, you see in Japan they have 10 electricity grids, and they are quite isolated. So there is no significant trade going on between those 10 grids. And the wind potential is especially the onshore wind potential is very, very unbalanced. There is a lot of it in the north, in the Hokkaido region.
Right.
And a lot in the south, but actually most of the people are in the middle,
Yeah.
in the Osaka and Tokyo regions. So one would expect that if the grid expansion were not to happen, then the onshore wind would not be utilized that effectively, because it can't reach, because there are not enough people to absorb that potential where it exists. So this study was a very nice way of quantifying this intuitive conclusion that most people who know about the country would reach. So let's make a scatter plot of, so we have offshore wind production on the y-axis and we have onshore wind production on the x-axis, and each of these circles is a different scenario. So there are, like I said, there were 100 plus scenarios. So let's not worry about that, but there were different assumptions on CCS availability and of course carbon prices. There were 10 different carbon prices, and most importantly, half of these scenarios allowed grid expansion and half did not.
Okay, that's this interconnectivity between the different grids.
So to say whether the wind electricity produced in Hokkaido can travel to Tokyo or not.
Yeah.
So So each of these circles is a scenario. So now, for example, here this particular one is saying ref 10 means the carbon price is 10, the highest level, and this has reference assumptions on everything. So you have 166 terawatt hours of onshore wind and 153 of offshore in 2020.
Okay.
Now, if you want to look at a different year, you just have to move the slider.
Ah, okay.
So in 2030, you see how the picture has evolved. And actually, you can also let it go as a movie. So this shows you how the onshore and offshore wind evolves over time.
It's slowly seeming to form two groupings here.
Yeah, that's a very good question. And actually, you can use the colors. You can use color schemes for the circles to identify what is causing which pattern.
Right.
So we would like to see that what has actually segregated these circles into two very different groups. And if you think about it, you see that basically the groups are characterized by higher or lower use of onshore wind.
Yeah.
You see that you have, so you have onshore wind going right up to like 280 terawatt hours for this group, while it goes all the way up to 400 and more in this group. So you can color these things on different things. So for example, if I use grid expansion to color this. So now you see the green ones are the scenarios that allow grid expansion, and the blue ones are those that don't allow grid expansion. So this means that you cannot use any more than, this is common knowledge that Japan has 400 terawatt hour plus of onshore wind. That's a resource estimate that most people use. But if you don't allow grid expansion, then you cannot use any more than 280 because of this locked nature of the grids. But you must, and if you allow grid expansion, then you can go all the way up to.
So that's almost indicating that grid expansion is critical for Japan, that they have to think about grid expansion.
Right. If it has to use the onshore wind potential, which is a competitive resource, then yes, it must look at. So you see, again, this is a lot of information on the same screen, and it would be very difficult to see this using the conventional charts.
Yeah. I think what I've got out of this demonstration are these marvellous visual comparisons, the ability to be able to select at will and then juxtapose sets of data. And of course you've got the super interactive element and these amazing animations. Is this available to the general public?
Yes, actually you can, when you come to VedaViz.com,
yes,
you can, first of all, you can see a wide variety of images that are already stored here to get an idea of the breadth and depth of analysis we can do.
Okay. As a member of the public, I could sort of view this in demo
Definitely.
mode. What if you were a climate scientist and you wanted to work with the data?
Okay, in that case, you should sign up. So you can go to the sign up page and just enter your details, and I will get an email telling me that, okay, you have signed up, and then we can interact by email, and you can tell me what you're interested in, and I can give you access to that particular set of results.
Perfect. Well, it's clearly something that, members of the general public should have a look at, but what a fantastic tool for climate scientists.
Thank you very much.